Hello, David.
Hey, Ken, how are you?
Pretty good. How about you today?
I'm doing great. Got a question for you.
Sure.
I went ahead and programmed the robot so it'd play my name in Morse code with the lights. How can but when I sit there and say do sound and then do lights, um, it holds up until it's finished playing sounds before it can do the lights again.
Oh,
Yeah.
okay.
Is there a way to
Yeah,
run those in
good
parallel?
question. There sure is. Yeah, it's a great question. So it would work like this. Once you get into multi-core, you might need to go to the reference just a little bit to get a few tips.
Okay.
But basically, your program could be built in the following manner. Let me start up a new
And
browser window.
I'm starting multi-core.
Okay, so you could
Okay.
probably, do you see my window?
Yes.
Okay, here's how you do this. Lights and sound, same time, I'll call it. So you have 8 cores in the propeller to choose from.
Okay.
And this is the way you begin them. You go into control and you get a new processor block. So I'm going to get 2 of them. And then you create functions. And so this one could be, the first function might be sound. And you'll run into timing considerations. You have to make these work together. And then here's light. And then those functions you put into the processors in this way. And so you would have in one of them, I can send you this program too.
Okay.
Here's your sound, your whole string of sounds, and you'll want to make, if you want it to match the lights, is that correct?
Yeah. Because if I'm
Because,
doing as I'm showing them how to do Morse
oh,
code, I
okay.
have them do because it teaches them how to build functions and such.
Okay, there are
Um,
2 ways to go about what you want to do.
okay.
Um, so you could match up the lights and sound this way. And so these start like a millisecond or a tenth of a millisecond apart. So they're basically in sync.
Okay.
Let me get a pin state just to make the picture complete. So you understand that with this frequency, you have a duration and then a frequency. So
Right.
that duration would have to match your durations of pauses here.
Oh, okay. That's easy enough.
Yeah, so then they go in parallel. So like, let's say you want a 1-second sound. You would do this. 1,000 milliseconds, whatever the frequency is, we'll say 800 hertz. And then you would make an LED on for 1,000,
Or
and
800.
then you would make it off. Yeah, whatever it is. So that sound will match that light. Is that clear?
Oh, duration. Yeah, where I was looking at frequency. Yep. Got it.
Okay, but there's actually an easier way. So we don't need to go to multi-core for what you want to do. If I
Well,
made
let
a
me
new
snap a picture
program.
of that because that's a good way to teach them how to do multi-core.
Oh, there's a whole world here. Here, I'll just save it for you too.
Okay.
Let me just grab a copy of that. Light and sound, same time. Okay, and then I'll zip that over to you. Open up my email really quick. And then your email, David, I might already
It's
have it.
DPAYNE
Okay, I'll move that off the screen.
at
St. Stephen's.
stevens.org. Yeah.
Okay. Let me copy that program one more time, and then I'll show you the other way to do it.
Okay. Yeah, I spent this morning moving all my programs out of the logon Blockly into solo Blockly. So
Yeah, you've been here before. You've been with us for a while.
been
So
using it all
you're,
for a while. Yeah, it's the first time I've had a chance to take a course with you, and it helps. I mean, even if you're doing stuff to just
yeah,
see, yeah.
you'll pick up some tricks. So the other way is just to turn the light on and off. Let's say you have, just do this. The duration of the light on becomes the frequency, like
Oh,
that.
okay.
No multi-core required, right?
Right.
However, you want to get creative and you want to find better and better ways of doing things. So the next thing you would do would be to use arrays.
Hmm.
Have you worked with them before?
I went through your examples
Mm-hmm.
on doing the arrays and cycling through them. So um,
Yeah, you
I
could
had
build your
some,
Morse code with arrays then.
yeah, yeah, I had some luck with that. But I don't think I put enough time into it to get fluent.
Yeah, yeah. That's what's really cool about Blockly is that it's a super language. It's programmatically structured and requires programmatic thinking, but doesn't require knowledge of syntax.
Yes, that's the reason I do it. I do it with my eighth graders, and I do it with my 12th graders who are taking engineering, so they get exposure to programming without having to learn syntax.
Yeah, yeah.
And so,
And for project-based activities, this is the way to go.
oh, that's yeah, so, and that's what I fly on. In fact, two of my students in engineering, they have to do an end of year project, are doing it on teaching the parallel the activity bots to run a maze and pop balloons.
Oh, great.
So
See, I would spend my whole life programming in Blockly at this stage because, well, when coupled with the propeller, it's super powerful and it's just fast. And
mhm.
I think visualizing what you're doing is easier.
Oh, absolutely, absolutely. It's the reason when on my intro to Python course I teach Turtle
Mm-hmm.
because it teaches loops and things. They can see things happening a lot quicker than sometimes just looking at printouts on screens.
Absolutely. So for you also, what you should read is in our reference guide,
Mm-hmm.
some of the blocks actually start other cores. And if you don't pay attention to what you're doing, like the servo block or the motor drive block might involve a couple of cores, and we explain that here. So once you're aware of that, you will not run out of resources.
It's right
You have
there.
to kind of take inventory of,
The
oh, is it under about multi-core?
oh no, that's right there for you.
Okay.
I thought you were looking for the block reference. And go ahead and make me co-host when you get the moment. But I'm
Okay.
so thrilled that you're looking at reference. It makes me really happy. I thought we only created them, but no one ever looked at them.
Oh no, this is the guide. This is the map,
Oh yeah,
the
I've run
Bible.
through that, and everything I've done in it has worked. I find your
Oh,
instructions
here.
pretty well written.
Oh, thank you.
This is what I wanted to show you. That's Stephanie's work.
Okay.
This is what I wanted to show you. New processor blocks. Stephanie, where's the list of blocks that already launch processors?
That is in the reference, I believe. Let's see if I have it listed separately. I'm not sure that I do. It might be.
So to get to the reference quickly, oh, well, you have
Yeah,
it
you're
right
right there.
Do you remember the name of it?
It might be a reference. Let me take a look. I have gotten to the point where I've about multicore in the reference. So click on the reference. It's the fourth one from the right in the top row, and then you were right there.
Oh, here we go. Okay.
Yes.
So, are you using David?
And so if you look down there, there are blocks that launch processors, and there's links to them.
Yeah, so this is what you need to be aware of. When using these blocks, they start processors. But otherwise, you could use that new processor block, put a function in it, and do things in parallel.
Okay.
And Andy, feel free to give me a shout if that needs updating.
Okay, yeah, so far it looks good.
Can I throw in one more question?
Absolutely.
When I'm logged into the online one, there's a community out there with a lot of projects people have done.
Mm-hmm.
But it's sort of hard to search and find for examples. Is there another place or a way I can search and find, for example, sound and fury kind of, or look for a word on the community? Maybe I wasn't going to the right place.
Well, there's a lot of what you see there is kind of student created, not very good, and then there's no links back to resources that it might use.
Okay.
So it's the best way to find. The best way is right here. Go to learn.parallax.com and then tutorials by language.
Right, and that I sort of live by going there.
Okay, that's the right resource for you. And then the other great thing to do, I don't know if you're a Facebook user, but we're posting stuff all the time on development on Facebook and also on our Twitter and on
I don't do
our,
Twitter, but I do have a Facebook
which
account.
one is your social media?
Let me go look.
Okay, so if you go into Facebook, it's this page. It's pretty much just a parallax group. It's called Blockly for microcontrollers. And I am continually depositing junk in progress here,
Okay, let's see.
as others
Parallax
are.
robots.
And
Yeah.
you're all invited too.
Okay, there's a Facebook. There's pictures of one of your courses. Home
And
shop.
you can go to Blockly for microcontrollers. You're on our Parallax page,
I
so do
believe
a search for another group. And that other group is called Blockly for microcontrollers.
Okay, let me find. I may have to go log into. Let me do it on my phone. I don't have the school computer set up for Facebook.
Probably a good idea.
Okay, search. Not Facebook, I don't have to do that.
So everybody's loading in. We have 20 on board.
Well, I didn't mean to take up everything.
No, this is fine. We have until someone jumps in.
There it is. Ken Gracie, Blockly for micro controllers in Rockland, California.
Yeah.
Now, are y'all near Menlo Park?
Couple hours away.
Oh, okay. Let me see where y'all are at.
But we are on Menlo Drive in Rockland.
Oh, okay. That's where I saw Menlo in there before. Because I was at a seminar last summer for up in Redwood. So, okay, cool. I found it. I will scroll through it and learn something useful.
Yeah. Well, everyone loads in here. I've got a neat application running. I think you could see a video.
Ken, you're lagging a lot.
This is a ActivityBot. Is it really slow?
You're getting some voice lagging. I don't know if you have some additional channels open that you need to close.
I will do that. Thank you. I'll go do that right now. Stephanie, I think Chrome was owning my machine at the last event as well. Is it better now?
Yes, much better.
You sound nice and clear.
Okay. Anyway, what's running in this video window of mine, if you can see it, it's a gripper holding a little yellow 3D printed cylinder. And there's another ActivityBot, and this is all done in Blockly, running a Pixie 2 camera. And it's tracking the yellow block. And this is a tutorial we're about ready to post. We have most of it done, but the few straggler pieces got delayed because of something called COVID crisis, and priorities got all shifted around. I think this is pretty cool because you could have your robot do useful work now.
Yeah, I left all my grippers at school. I left all my grippers at school, which was silly because I was going to try and play with them. Because we just got notified we're now going to do distance learning for an extra couple of weeks. So I was I got all the spare time, I'll play with it. But then they're all in a locked up building. So,
oh, bummer.
So I ordered what y'all had on your website, but y'all were out of grippers.
Yeah, this one's new. It's just getting manufactured right now. Coming soon. I keep showing it even though it's not available, driving my colleagues crazy.
Well, I have the old ones at school.
Those are just as functional. So for all of us loading in, Jeff, our software engineer, alerted me there is some intermittent problems with downloading on Blockly Prop today, and just kind of curious if you all are seeing that when we start using it. So just give a shout out. We need to hear any problems so we can make things work flawlessly.
Joel, can we unmute you and have you tell us what you're seeing?
Yeah, I've been working on it for about the last hour. And sometimes when I try to transfer the program, it got all the way to the very end, and then the last two items, it failed out, and then I waited a while, it failed, and then I waited a while, and it worked. So it's just that word intermittent seemed to be my experience, and I thought it was on my side.
Okay. But you were able to succeed after retrying?
Yeah, yep. It wasn't like,
Okay.
it had been working flawlessly for about 20 minutes, and I'd done several tests, and then all of a sudden I had about a 5-minute span, I suppose, where it wasn't working, and I looked around, read a few things, and I tried it again, and it downloaded. I went and tested that code, and it worked. So intermittent is the word I would use, and I assumed it was on my end. I'm glad to know it's not on my end.
Yeah, we wish it was on your end. But so this is part of that is us moving from one system to another. We had to rewrite several portions of our tool. We used to be in the cloud exclusively, and we're making things work a little differently. And Jeff is our engineer. He's monitoring this, as is Jim. But we'll have this working as flawlessly as it used to work on the cloud. It just takes a little bit of time sometimes to shake it out.
Yeah,
But
this problem
because
seems
Chrome and
cropped up recently in one of the releases that we had. I'm not sure what changed, but I've been trying to track it down. On my side, it seems to happen. It seems to happen more often if I have a number of applications running on the computer. So I'm thinking that it's related to processor time issues, and probably just something that I need to optimize in the code to make it download more reliably.
that's awesome, Jeff. Thanks. We're glad you're here. Yeah, so we'll ask you all to bear with us a little bit if you have trouble. I think we can get rolling. We have 31. Well, just wait one more minute. Any other questions that want to be answered could be answered now too.
Hey, good morning, guys. Yeah, I did notice I switched. Yesterday I was using my home PC and it was working fine. I really want to do this on my work computer because I'm assuming that's where I'll be doing most of my work. They granted us an admin rights so we can download stuff in our work computers, which I did and have been using that for the most part. But today I did notice that I've been able to use my work computer fine, my MacBook, but my home PC is not working right now for the Blocky Pop Solo. Is that what everyone else is experiencing?
Jeff, mine's worked fine this morning and I'm using an older Chromebook.
Okay, thank you, Steve. Marco, are they two different operating systems, or are they both Macs or both Windows?
They're both two operating systems. The Mac is working fine, the Windows is not working.
Okay. Thank you.
Yeah, and any intelligence of what you observe, you can throw our way as we go through this too today. We welcome it.
Just a quick question for Marco. Did you just recently download and install the Blockly Prop Launcher on both your Mac and your PC, or is your PC possibly an older Blockly Prop Launcher?
No, I just downloaded it. I downloaded the Blocky Prop Solo, let's see, I think maybe a day before our last meeting. So I used it exclusively for the last meeting and it worked fine. And today it doesn't seem to be starting up or it's having trouble connecting.
And so on both machines you downloaded the very, very latest. So we're wanting to look for some possible issue with the latest version of Blockly Prop Launcher on a Windows machine. Is that right?
That's correct. They're both the latest version. Downloaded both versions just within the last few days.
Okay. And is it Windows 10?
I believe so. Double check.
Okay.
All right, let's get started.
You're bouncing again.
Today was a good day. Okay. let's see if I can simplify the setup a little bit here. Maybe I'll close out some Chrome. I am wired. I have super high broadband. Okay, audio a little bit better now?
Yeah.
Sounds good to me now.
Yeah, just let me know. Okay. All right, today. So a few public service announcements first, and then we'll get into navigational type things, and I want to hear how that went for all of you. First off, goals for today. We want to finish up some navigation, and I want to hear how that went for everybody. We're going to look at the propeller activity board, and we'll also build our first major circuit, which will be whiskers. And that went pretty well in our last class. I think we can achieve all this. We keep moving quick. And keep your chat open. Bring us the problems that you're experiencing. I have Stephanie, Jeff, and Andy here. It's amazing. You have like 4 parallaxers here to help you out. So absolutely utilize us. I want to remind you that we have some awards going on tomorrow. We have an award ceremony at graduation. We actually have 3 categories. This says 4, but we are definitely getting entrants from our prior group. And I don't know if I covered this Monday or not. I may have forgotten it, but category 1 is the funniest animal or coworker. And some coworkers mean now that can be anything, any kid, pet, whatever. Category 2, the biggest fail. We had a great entry for that yesterday. One of us proclaimed after everybody left that they cycled through not 1, but 2, maybe 3 batteries on their zero-turn lawnmower, zero-turn radius lawnmower due to miswiring before they figured out what was wrong. So that one's definitely a big fail. And then category 3, biggest winner for tomorrow, bring us your stuff, your cool stuff done on the ActivityBot. And I don't want to set the bar too high for you, but this does not apply to our group since we haven't received anything back from you yet. This is in our Python programming session. This is Brother Jack, and he had to make his submittal with the snake around his neck. So that's going to be hard to beat, isn't it? All right. Moving on. The gripper. One teacher asked about the gripper that you're seeing in the videos. So this is a new project we're working on. It comes out very soon. We're just machining our last parts on our CNC mills. We've made 100 kits. If you want to make your own, you could do that as well. And I have seen impressive things done with very simple, small amount of material, mainly a hot glue gun, such as that, box cutter knife, and then I always start with foam core board like this. And you can go to parallax.com and get some standard servos. And people have done some impressive stuff this way. You don't have to buy our fancy one. Of course, we want to sell it to you too, but it's not necessary. Also, C tutorials. I don't think I mentioned this too well the other day, but we have 2 series of tutorials for the ActivityBot. Today, I'll show you how to go between the 2. But they're both parallel, and you're looking at the C version right now. So it's the same projects. We'll just get a quick look. I'll do a screen share. And you can pretty much grab the code out of Blockly. It will look very similar to this. And I'll show you how to do that. So last Monday when we quit, I asked if you could run the tutorials for basic navigation for the ActivityBot. And I would like to know how that went for everybody with Blockly. Navigation basics. Maybe a thumbs up on this or a thumbs down would be helpful. Good. Lots of success. Okay. Everyone felt pretty good about that. Looks like some didn't find the thumb up or thumb down button, making comments, which is fine. I don't know where the thumb up or thumb down is because as host, I don't see that, I believe. But okay, that went well. So what you may have seen, you're starting to see some of the power of the ActivityBot. I want to draw your attention to the motors that are used in it briefly. So I'm just going to go over to Parallax's page. The ActivityBot is our most capable robot, like I've told you before, and it uses something called the Feedback 360 servo. And this servo has on it this yellow line that you hooked up, and that yellow line gives a signal back to the propeller activity board, and our library is doing some calculations to allow you to specify distances and speeds because of that. And this is a huge boost to be able to drive centimeters, clicks, ticks, or whatever you choose, or inches with the robot. And it's fairly precise too. So not available in other robots, and the complexities of it are absolutely abstracted for you.
So Ken, on the web page you're on, if you scroll down a little bit, there's a I believe it's in downloads and docs. There's a little video clip of some of the fun stuff you can do with controlling the.
It would be under.
Oh, it might be this image.
Oh, there it is. Yes, you're right.
Yeah. Yeah, so this is showing you, I'll just enlarge that. Can you hear this audio, by the way? I don't know if you guys get the audio.
A little bit.
Okay.
So see the white dot on the edge of the wheel, how it went to 45, then negative 45. Now it's up at 90. And the values that are typed in on the bottom of the terminal is where it turns. So negative 720, it did 3 full revolutions to get there.
So I think that is really cool. That's a wonderful feature of the ActivityBot. So since everyone's had pretty much success with that, what I would like to do is just show you a few advanced ways of using those drive routines. So I'm going to open up a couple programs. And you could also run these if you'd like. The first one is called Navigate with Functions. And I think it's an easy enough one. You can just write it when it comes up here. I'll show you how to write. I intentionally did not produce too much because it can be very time consuming until you become quick with this code. But this program would be just first go to robot and then get the initialize block. I'll build one side by side so you could see how I got this. And then I grabbed 2 functions. So went to the function menu and pulled one out. And instead of going back there, since it was already selected, I just did a copy and paste and got a second version, and it renames it something different for you, which is good. So I just called the first one straight and called the second one back. Actually, I might even call it right. I'll call it right. And then I went to the robot blocks, and I grabbed a few of the distance-based blocks. And so I'll bring one out. And then I'm going to bring out a second one. I'll clean up my program here in just a minute for you. So once I've created those 2 functions, which are named straight and right, they're available in the function list, and I can go grab them. So you click on functions again, and part of the whole syntax complexity, syntax proof, trouble-free code is that everything is named right. So you can't call a function that you didn't already name. So there's no misspelling opportunity here. So I'll grab straight, and then I'll grab the other one I made, right. Okay, so to date, you've been seeing code just getting stacked with long blocks, and this is what students will do to achieve things, but there are far better ways, as you know, to optimize and make things more efficient. And you have plenty of memory here in this way, and I've not run out of memory programming in Blockly Prop, but it can happen, but I don't think it's anything you need to worry about. So after you've got a program like this, which uses functions, which I think you're probably mostly familiar with too, because you've done this before, some level of coding. I'm going to train this on my robot. So my robot, I'm going to ask it to drive straight, and I'm going to choose a small number of ticks, just like, I don't know, 30, and then 30. And then I would like the left wheel to keep driving, so I'll make the left one 30 and the right one 0. So what we're after here is drawing a square eventually, and a square is made by going straight, right, and then doing it 3 more times. So to test that out, I'm going to download, and you might notice I have no cable today. I have something called the WX module in my robot, and I'm wirelessly programming it. Okay, but that's because I don't like getting the cable all wound up in things. So I'm going to download. And I might have my own problems with downloading wirelessly. I like to find the limits of practicality and push it live in a webinar or Zoom meeting, right? So I'll just leave the robot on now. That's the result that I got. So it went straight, and then it did a little bit of a right turn. I'll reset it and run it again. Didn't turn enough, so maybe like 60 ticks on the left represents a 90 turn. That.
We're getting a message that says Ken Gracie's network bandwidth is low.
Oh, okay. But you still see the video audio okay?
It's pausing.
It's pausing for the moment. Okay, let's see what I could do to shut things down. I don't really have anything else open I can shut down, and I'm wired. Okay, just keep watch on it. All right, you can't see my screen though, right?
Mm-hmm.
Okay, good. All right, so the next step here, since we have some repetitive motions here, is we'll just make a loop. And there are a couple ways to do it. You could take repeat forever and change it to X times, and then drop those 2 functions in there.
Ken, are we supposed to be seeing your program right now?
Yeah, do you not?
I don't. Is everybody else seeing it?
I'm seeing it.
I mean,
Yeah, I see it.
switch
I can see it.
on the
Okay.
side, just switch. You might have a screen versus the shared screen. Switch the swap shared screen with video.
Yep, I just did reshare on my side, so it might be
Okay. I think I have something weird on my Zoom. I'm going to get out and get back in.
that I'm missing. Okay, yeah, it's always a good idea. All right, so you can come in here and then just plug in, get a value, a number, and then plug it in to here. Oh, where is that? Values. All right, and then repeat this 4 times, and we'll just watch it run. I'm going to shorten up a little bit so it doesn't actually get off of my table. Awful lot going on to demonstrate this kind of thing. And the download. Oh, okay, there. Seems to have taken it anyway. Oh no, it's running the prior program. So we'll begin. One, 2, right turn, 3, and then 4. So there's your square, but of course you could fine tune it to be just right. All right, so that's a little bit simpler. And then here's another way that might also be nice to do longer kind of open loop, no sensor feedback coding. It's using arrays. And realistically, when you're using most of our robots, you're actually navigating in real time with sensors. So you don't have these commands that just send you driving while you're not looking at the road or looking for obstacles. Navigating with arrays. Here's another one. I'll send these off to you today, so you don't have to copy these or try to snap pictures. All right, so Blockly Prop is really a fully featured programming language, and here we made 2 arrays. We made 2 arrays with 10 elements, but I didn't populate them to that extent. And what I put in here were just driving ticks or values, which I treated as ticks in the repeat loop. So I created 2 arrays and I filled them up and I put 4 values in each. And then I had a repeat loop. I just stepped through the first 2 values of each and I dropped them into the left wheel and right wheel. And item is just indexing through this loop.
Quick
So this is,
interjection, where you see robot drive distance in ticks, there's a drop down there where you can choose between ticks, centimeters, and inches. Ticks are nice. They're the smallest increment. It's basically a 64th of a wheel turn, and that translates to about 3¼ millimeters of rolling on the ground.
so as an example here, I'll just let's put in four elements, 4 numbers for the left wheel, and then for the right, 20, 0, 20, 0, and then we'll step through all 4 of them and see that run. So here now we only have 1 distance drive block, okay? And we're able to execute quite the pattern. Let's see how this works. Oh, well, pushing the limits again, probably my bandwidth issue here. All right, here we go. So I'm seeing both wheels turn, and then I would see just 1 wheel. And I'm writing a program that's kind of hard to see because I don't have much space on my table, but straight, right. Got that? How do you like arrays? Thumbs up on arrays? Yeah, I do. And oh, just for fun, how can you use them otherwise? Let's go look at an example project I have. And then we'll get right into sensors. So you're able to hear the audio from the last video that I played, is correct?
Very faintly, it was just coming in your microphone. It's not broadcasting.
Oh, okay.
Through your mic.
Gotcha. Then this probably won't do any good either, so it won't show up. But where they're really useful, we had someone here earlier who was writing Morse code, all right, or composing songs. So here's an example with songs that have notes, durations, and rests. So this is a video that's on YouTube. And I'll forward that link later today. It's a Super Mario song. All right, shall we move into sensors now? Okay, I'll take you back to the tutorial. We are here in navigation by touch, and we're going to build up our first sensor. When you come into these tutorials, you'll see consistency across all of them. And the normal view is like this. You enter it, and there will be a video that demonstrates what the circuit should do. All right, and it's super short, and it is on YouTube. Hopefully your school doesn't block YouTube. That was the whiskers. Let's watch it again. Okay, so you can detect an object on the left or right side. And as you scroll down, we have this in steps. The first one is to build it and then test it. And then we test it with a wheel, and then we show you how to roam. So this happens very incrementally. It's quite common for a student to bring you a big mess of wire like this and then say, hey, it doesn't work, what's wrong? Well, you'll usually need to direct them back to where it was working. Taking parts off the board, going back to a prior code version. And that's how we do engineering at Parallax too. We have many versions of all the code and software we work on, and we will go back. I think that Jeff for Blockley probably has 1,000 versions. So building the whiskers, I think we can do this together because there's some questions that will come up, and it's a great learning circuit because it has just about everything. It has mechanical dependencies, it has resistor values, and it has breadboards. If you haven't used a breadboard before, let's take a quick look at that. Maybe give me a thumbs up or thumbs down on breadboard experience here. Okay, all right. I'm trying to guess probably about 3/4 of you have breadboard experience, and that's fine because we'll get all the right questions asked. Okay, so on your ActivityBot, on the Propeller activity board, you'll see a breadboard, and this is a place where you can take little electronic components and build them up into working sensor circuits. And this breadboard is on the front of your robot so that the sensors you place there can interact with the environment when the robot's going forward. Main thing to know about this breadboard is that the rows, the holes on the left side, like you're looking here at the top left, are all connected. So if you plug something into this first one, row 1, column 1, it's also connected to row 1, column 5. There's a little metal strip underneath that connects them. However, there's a plastic center of the breadboard that separates the left side from the right side. So as an example, let's look at this picture on the left. You see the yellow wire coming in, and there's the blue wire. Those are connected because they're in the same row. On the right side, you'll see a picture which shows them almost connected, but doesn't count, not connected. All right, so they have to be exactly in the same row. Down lower on the left breadboard, which shows things properly connected, we see a yellow wire coming in, and apparently the goal here was to connect it to the wire on the right side of the breadboard. We did that with a little wire in between. Okay. On the right side, we have a failed attempt at that. Not connected, not good enough. So Parallax tutorials will have in them physical setup as required of the system you're building, what we call a pictorial. That's this picture. Okay, that's a picture of the circuit, and then a schematic. And students often will start out very literally following this tutorial, but may not understand the breadboard, will have things just shifted off a little bit, and it won't work. But in time, they're just going to get better and better. They will be able to read schematics shortly. So you'll always see these two from us. We're very component-based in everything we do. And then as your students progress and they want to combine whiskers with infrared or whiskers with ultrasonic, they will get tighter on breadboard space, but usually it can be done. We have projects where every single row is used on a breadboard. So this is a lot of working real estate. Okay, did I miss anything? Should we get building here? All right, so we could start building this circuit, and I think it might be good if you opened up the tutorials too in your Chrome browser and had them handy. And we're gonna need to collect up some parts. This is tricky. If you are over 40, you will not be able to see all of the resistor values. Is anybody here over 40? Okay. Can you see, Alan? All right. It might help to have a light like this to magnify, but we just have to roll with what we got. If you got a kid handy, maybe they can read them for you. Resistor color code. We're going to use 220 ohm resistors on this, and then 10K ohm. So here on this picture, 220 is red, red, brown. And 10K ohm is brown, black, orange. So you need to find 2 of each of those. I believe they're in 2 different bags. Maybe someone can confirm that. And also, as running a class, we see teachers get anywhere from 1 to 3 or 4 years out of using these parts. These are really dirt cheap components to replace. We have a bag of them that has all the little components in it for $13 you can buy. But the resistors you can usually also buy from Amazon or wherever. They literally are fractions of a penny. Everybody's working so quietly. And I have a few pictures I will bring up that I just took a minute ago to just have visualizing. Stephanie, is the bandwidth holding together?
I'll jump in for Stephanie. You sound good over here.
Okay.
Ken, David's asking why one above the washer and one below. Physical separation?
Yeah, and it's really okay. They're going to hit each other. They will touch each other. You'll know which one is activated by what we call these 3-pin headers that are going on the breadboard. But yeah, if you put one above and one below the washer, it's just a little easier that they will not conflict, but it's totally fine if they do.
Yeah, the thing it was designed to avoid is the left whisker bringing the right whisker with it, even though something's only pushing on the left whisker. And the idea was if they were above and below each other, they'd be less prone to, one would be less prone to catch the other and push both of them when you're only pushing one.
And building the Blockly code for this is going to take a little bit of time too. I wonder if there's a way to distribute a file on Zoom. And here's a picture of my circuit at present. Stephanie or Andy, do you happen to have this pre-written code in Blockly? I don't think I do. So it might be a good experience using Blockly. We can all build it together. I think it's important, just like writing code, using Blockly to generate code, finding out where things are. That's the biggest question teachers have. Where was that block? And especially when we create blocks that are variable names, they look like blocks that are already defined. It can be hard to tell things apart. So people will likely have questions about these little 3-pin headers, and you can see they just drop into the front of the breadboard, and they will allow you to detect the signal level with your I/O pin. And the fact that they're 3 instead of 1 is just to provide them some mechanical stability. Yeah, everyone wants the code now. Nobody wants to drag and drop the blocks, but I don't think we have this particular code handy. think it's okay because I think this is about a 2.5, 3-minute code build.
Ken, I have a question about moving since we're waiting.
Sure.
Okay, yesterday we did a robot set acceleration for distance in those ones. Now, is it supposed to start off slow and then immediately go to the speed that you have it set to instead of seeing a gradual?
Andy, do you want to take that one?
Sure. By default, it's supposed to gradually speed up. Not overly gradual. For example, if you're watching it speed up and it seems to speed up over 2 or 3 seconds, that's unusual, or it would be something in your program that slowed down its tendency to speed up. It does by default gradually speed up over a short period of time. I think, it takes maybe half a second to a second to get from 0 to full speed.
Okay.
And then there are blocks you can use to adjust that tendency to have it tell the servos to go to full speed immediately without taking any steps from 0 to full speed.
Because it looked like when I ran it, I did some different numbers. It only went, a short distance at a slow speed, then all of a sudden went straight to the fast speed.
Okay. Did that program combine distance and speed blocks by chance?
Yeah. Well, I have robot set acceleration for distance to 50 ticks, which is the sluggish.
Okay.
And then I have robot set speed for distance at 128, so I went to the full speed.
Okay, yeah, and so there should be a set acceleration level for speeds as well. So you could actually set the acceleration for both the distance and the speed, because when you're setting it for distance, then you use a distance block, and yes, the acceleration will be gradual because you use the most sluggish 50 level.
Right.
And then if you do the same thing with the set acceleration block, but then specify for speed, you will also see it for it responding.
Okay, so I have to add those other blocks in there to get it to do a gradual.
Here's an example, Steve. Look on my shared screen and you'll see. So initialize block is always required, and then you can set acceleration for speed or distance.
And you can even copy that block and set them for both. So like if you
Right.
make a copy of that block, you'll set one for speed and the other for distance.
And we should be totally forthcoming and point out we do have a bug in our drive commands where you should not mix speed and distance blocks too freely. Stick with one or the other.
Now, a little bit extra on that, since the bug is actually my fault. I made some adjustments to the code under the hood for a product we have that has the ActivityBot called the Parallaxy. And in doing so, I ended up adding a bug where you might have a program that uses some speed blocks and some distance blocks. And I forget whether it's switching from speed to distance or vice versa, but in one of them, if you're executing a turn, it doesn't execute the turn properly. And so if you see funny behavior on turns with mixing your speed and distance blocks, that's the problem. But that brings us to another thing, which is things are pretty regularly updated inside Blocklyprop. And so as soon as I fix that bug that I inserted into the control system code that's under the hood, we put it into Blockly right away. So that bug will go away hopefully soon.
Yeah, the benefit of a cloud-based system like this is that you're drawing from our servers every time you open the latest version of Blocklyprop. It's always there. So you will not come back to our hardware in weeks or months and have things broken, because you didn't upgrade your software and go through all that stuff like you might have to with CAD or CAM or licensing tools, generally should not be a problem.
In this particular instance, if you just put a robot drive stop block in between a drive speed and a drive distance block, there is no problem then. That's documented in
Excellent.
the help. So that's in the help.
Great.
Reference.
Oh, thank you, Stephanie. That's
So-
also a good hint for me to do the troubleshooting.
If you're already here, you could start building this program. I'd be happy to walk you through it and show you how I would put it together kind of efficiently. So I'm going to take this tab to another display so I can see the program. And then I'm going to start with a clear blank slate. And we're just going to assemble this together for those that want to follow along. Just pausing for a moment to get everything right here. I could use about 4 or 5 more monitors at the moment. Then I'd have 4 or 5 times the problems, right? Okay, so the tutorial page has the code. You might want to set up your browser side by side, or you could just follow me. So the very first thing, and this is just to test it. We do these things in small steps. We'll test it, then we'll add in some drive routines. And we may not have time to get to the drive routines today, but we'll see how it goes. So the very first block I see is a comment block, and that's under control. And I know from the color of the block that it's keyed to the same color on the menu. And comments, you can just put anything. I'm just going to call it whisker test. And this is straight out of the tutorial. And then I see a terminal clear screen. And I don't think we've used terminal yet. This is great. So terminal will open up that black window. I think we did use it, yes, Monday actually. It'll open up the black window and send data back. So we need terminal clear screen, which is under communicate terminal. So these are we've tried to group these in a sensible fashion. Like other things you'll see in communicate are for LCD displays, for graphical displays, for wireless, that's all communication. So get the terminal clear screen block, come in there and drop it on. And then you need a frequency block. If you have a speaker on your board, this is good. Frequency is under audio. And it's the first one, frequency out. I'm not sure if this, actually that tutorial does have a speaker on it. So if you have a speaker, you will hear sound. It's wired on pin 4. And then there are 2 things you can enter here. One is the duration, and then the other is the frequency. So this will make a beep. So if you don't have it, it's okay. And then I see this repeat loop. Repeat loops are program structuring commands. So it's in control. So go up to control, and then you'll find repeat forever. Grab that, drag it out. Isn't that snap rewarding when you hear that in Blockly? What do you guys think? Thumbs up on the snapping? Yeah. What if you could change it to other sounds like a crocodile or a dog barking? Oh, by the way, we did receive an entrance into our funniest coworker, which I did flash on the screen, but I don't think anyone saw it. So let's just get a look at that really quick. This one's pretty darn good too. It might be a winner, we'll see. So it's from Cheryl. Is that for real or is that stuffed?
Oh, wow.
She's got to be a hunter. I'd say it's stuffed.
Those horns are awfully glossy.
Yeah. So far, though, it's looking pretty good. Okay. I'm not here to have fun. Let's get back to work with this stuff. All right. Then you see 2 variable blocks. And those are purple. And you won't find any blocks that say WL or WR, so you're going to have to make them. So come into the variable menu, and then you'll see on top, new variable. Click on that, and now you can make that block, WL. Click OK, and you'll see it's now available in the list. Then you could click on new variable again and make WR. We should have hired Bob Ross for this job. He's a calming voice. Okay. So once you've done that,
And you're definitely the next best alternative.
quietly swipe your Blockly code over to the side. All right, it's not funny, Linda. Let's get back to work here. All right, so I copied it into the loop, control, paste. You can do Control-C, Control-V to get another version of it rather than dragging it off the list. So the first one is WL, and the next one is WR. And then it's check pin. So we're going to get the status of pin 7 or 8, which will be high or low, and we're going to stuff it into this variable. So pin states are this tealish looking color. So you can go to that menu and then find the version that looks pretty fitting. I'm going to get the third one down. You'll need to configure it for the pin that you've wired on the breadboard. So you could see the room here for errors. Everything has to match up perfectly. Your code has to match your circuit. And about now, you're probably being prompted to save. Any questions so far? Everyone's getting along just fine? Okay. All right. And then we have these terminal blocks. Okay, so we have to format the way the display comes up on terminal when we test this. And if you've worked with Timex Sinclair, for any of us are old enough, or Commodore 64s or old Apple IIs, this is very familiar to you. You can't just splatter data onto a display and expect it to be all formatted right. So you have to do some formatting. So we're going to print numbers and text. So you can go into Communicate and then Terminal. And I see we're using the terminal print text and terminal print number. Those are the first two blocks. So I'm just going to grab them out while I'm here. And you can use your whole workspace as kind of a scratch pad when doing this. I find that's very handy. So the first one I'm going to drop in, and we have labeled it left. And this is just a text string. This is not a variable name or anything. And then right under it, we have terminal print number. So we're going to display the state of the left whisker. And it comes up with a constant because it's a number variable. You got to pull that constant out, then go back to your variable list and get WL, which stands for whisker left. And if you're really having fun, you can do this in hex, binary, or ASCII or whatever. We're just going to use decimal. And then click that, then a new line checkbox at the end. Are you guys following this, by the way? Okay. Is this working all right? The pace is good? Okay, no problems. All right. Okay, we're going to speed it up to twice then. So hang on. Oh, just kidding. All right. So I like to copy and paste. I don't want to have to redo all this stuff. So I see that we're repeating for the left. We'll do the same for the right. So you could grab that top one, Control-C, Control-V, do the same for the bottom one, and then stack them in the right way. And then the changes you would make are changing left to right, and then pull the drop-down menu for the variable and change it from WL to WR on the second one. And then there's a pause, and that pause is here because we don't guard against realities here. You can flood your terminal and it will get clogged up. So we put a pause in here of 150. You can basically overflow it. And then we put a clear screen at the bottom of this. And we do that. Why do we do that? Someone say why we do that. Why do we clear the screen? If we don't clear the screen, Yeah, you're waving with your hands like you're explaining it. You can't read your lips, but
basically it means the reason we do that is because that way the display keeps on appearing in the same position in the terminal. If we don't clear the screen, it will automatically scroll down and you'll have to look to the bottom to see the latest.
And we'll show you both versions of that. Okay, so we got a program that took us 7 or 8 minutes to write. It wasn't bad. And then you can download it. If you have multiple things hooked up to your COM ports, be sure you choose the right one. I have that wireless robot, which I called ActivityBot 360, and then I have COM19, which I'm hoping is this robot. We'll find out. So I'll download the EEPROM. And then I'll see this terminal menu. Okay, great. Terminal display comes up and it shows me the left. When I don't touch it, it's 1. When I touch them both, the pin goes to low and the display will show 0. So if you look at my video and then also the screen, you'll see I'm alternating between left and right whisker to demonstrate this. So you can do a physical arrangement test here, see that things are working right, pretend you're a wall so that when your robot encounters it, how much force do you really need to actuate this whisker? And one of the things I like to do about now, Andy? Yep.
Oh, sorry about that. This is also a test that we try to reinforce with the students that, hey, before you move on to trying to make the robot go with the whiskers, you need to make sure that you get a 0 when you push on the left whisker. You want to see left equals 0, right equals 1. And then likewise, if you push on the right whisker, you want to see right equals 0. If either of them are stuck at 0, the program that makes the robot navigate will think, hey, the whisker's always pressed, so I'll just keep on turning to try to avoid an obstacle. And students tend to run into problems by going quickly through the test and not actually verifying that they get that 0. That's one of the most common mistakes I see in classrooms.
I'll get back to the code here. I took that off the screen. All right. So how are we doing out there with the whisker test? Oh, good.
Well, it came up with 1 fail. I didn't change WL. I had 2 WLs instead of a WL and a WR.
That's a pretty good fail, but doesn't qualify for the awards yet.
Just one of those stupid ones.
Yeah, this will happen. And so it brings up a good point. A second set of eyes can be tremendously helpful. You're all working alone and we can't even see what you're doing. It's pretty impressive that, 70 or 80% of you are getting it. This school closure thing in some ways turning out to be a wonderful opportunity to learn new stuff, isn't it? I think so. And once you've tested out, you can actually move into roaming with whiskers, or there's an intermediate program on the next page, and get that code going. I have a question for all of you too, maybe you could answer in the chat, which is I was reading last night about whether or not you can grade and test while you're in this zone of school being closed, or if it being an equity issue of access means you can only do experiential type learning and enrichment. Which is it, the former or the latter?
Here in Louisiana, we're not, or at least in Bossier Parish, we're not grading anything. It's all, in fact, we're not even really allowed to do anything new. So we're basically reviewing things that we've already taught, and all of it is optional.
Wow, is that pretty standard then around the country?
In
No,
Iowa,
I see some.
the governor just gave us the choice. It looks like that either we can continue giving enrichments but no teaching, or we can do required work, and that is probably up to each school board on how they proceed with that.
So it truly is a mix.
Our school is
Well,
continuing.
I'm sorry, I've got an engineering class where we're doing the robotics and we're continuing on. And I also have AP classes where although it's shortened, I still have to do all of the computer stuff. So we just keep moving. We just keep moving. Now I'm in Illinois, by the way.
Yeah, interesting.
AP.
I'm in Wisconsin and we keep going.
Yeah.
Sorry.
Florida, same thing. Our schools keeps going. They've just shortened the AP, so we're not covering as much material.
Well, it's times like this I wish we could put a robot in every student's hands right now. Okay, so if you've got this working, has anybody built the program for driving the robot around? This is a good one to learn about if else and how to get it to work right. So let's just do that briefly. I'm going to set things up so I can walk you through how to do that. So you could basically, I'm skipping an intermediate program that is this one. Take you back there. I need to show you the if then else setup so you can do that successfully on your own. So the second program is whisker wheel response. And actually we could use this one to demonstrate this, and then I'll leave the roaming up to you. So how do we get this if then else? So we want to modify the program we've got to look like this. So everything checks out with the whiskers so far. And we will then take our program and change it up to look like the whisker wheel response. So it looks like everything, we don't need the terminal stuff anymore. We know that works. So everything from the first terminal block to the last one can be deleted. Now here's a quick way to do this. Rather than clicking on each block, if you grab the top block in any section, look what it does. Brings out all the blocks below it. Okay, so your two approaches to deleting this are to click on each block and go through this, hit delete key, or just grab the top one and then you can take them all out at once, just like that. Throw it in the garbage can. Okay, so now we want to add in the if, do, else statement. So again, that's a program structure command. It's over here. And I am not seeing it. Oh, here it is. Yeah, I couldn't see it because of exactly the point I'd like to make with you. I was looking for if, do, else, and all I saw was the if, do block. So how do we get this to be an if, do, else block so that we can check two conditions? There's a little gear here. Those of you who are familiar with this kind of thing, okay, the configurator, I see some of you nodding your heads, all right? If you're not familiar with this, you'll spend 20 minutes looking for the right block. But it's just the if, do block, and this configurator button allows you to drag in here else and else if. So I think I need 2 of those. And then when you're done setting it up, how come that's not working?
You are using 2 else.
Oh, I need else
Else
if.
Yeah.
Okay, and I need to put them in the right order too. Oh, it's only going to let me put it.
Yep.
Okay.
You only get one else and it's always last.
Okay, so I have 2. Oh, that's right. Isn't it? No, that's incorrect. We'll start with a fresh one here. There we go. All right, so once you've got it right, hit the gear and close it. Thank you, co-pilots. Putting the wheels back on the plane for landing in 10 minutes. Okay, so the gear, you see how I futzed around with that and fumbled? Yep, it's okay. All right, and then, oh, how do we build this complex looking statement with this math in it? So to get a look at what I'm talking about, I'm going to drag something back here. All right, it is this block if left wheel equals 0 or right wheel equals 0. I like to build these from the inside out, so I'd start with getting an or block. And that is under operators, numbers, and it is the currently shown as and. So you can bring that out, and then it has a pull down menu, and you can change the and to or. All right, and then you'll see there's an argument on the left side and the right side. The argument on the left should say left wheel equals 0. So something equals something. That one is right here. Operator numbers. And I just have to change that. Oh, wrong block. Wrong block. Ah, it was same, just lower in the list. Operator numbers, and then look for equals down lower. I'm going to copy it and paste it. And that's the beginning of it. So then you need to put the variables in here and then a constant here. So I'll do that really quickly. And then I need a few zeros. I'll grab those out of numbers. Oh, not in numbers, values, sorry. Okay, so if either the left or the right whisker is touched, meaning the IO pin goes low, then we want to turn or we want to send the robot backwards. So drive speed block is needed. Get one of those. That's under robot. We found that before. And here we're using speed-based blocks. Oh, and then I see this came up. I have an exclamation point. Something is wrong. If you click on it, you must use a robot initialized block at the beginning of your program. Somehow mine, oh, I guess I never had one, but now I got one. And I don't need that terminal block, just delete that. Okay, so we want to go backwards if we hit something, not forwards. Turn away from the danger. And if there's nothing there, we just want to sit still. 0 and 0. Another pro Blockly user tip, if you right click on the block, you can change it from external inputs to inline, and then your code will be a little bit easier to read. Are you all about in the same place as I am? No? Yes? Okay. Some thumbs up, thumbs down. Everybody have this program up? Thumbs up or thumbs down? All right. Okay. Got some pro graphical programmers out there. Cool. Well then, yeah, download it. Let's see what it does. I will spot my video for you so you can see it. So here we go. First test. I'm heading in to touch the robot. Oh, doesn't go backwards. Fail. Okay. The power switch is in position 1, so my motors are not enabled. I'll switch that to 2. Try it again. Oh, I like that. Okay, that's working. Cable's in the way, so I'm just going to remove it and try this again. You should see something like this. And I noticed on one of my whiskers when I pressed on it, it was hitting the black plastic housing on the 3-pin header. So you got to look at what's happening when you actuate that whisker. Any successful robot backups going on out there? All right. Just don't back off the table. Okay, I think you're all doing great. Let's take questions and then we'll head towards wrap up. You can unmute your microphone or you can type.
Quick question.
I had a question.
Yep.
Go ahead.
Oh, ladies first. Okay. Earlier in the function program that you showed us, where you had a function for forward and backward and making the turns,
Mm-hmm.
is there a way to introduce? I can never remember the word, but basically variables where we drag that block out, and then tell that specific block how far we want it to go?
Yes. Yeah. So if something equals 1, 2, or 3, then do a function like that. Yeah. I mean, you could do that right here. So on this program, this is a condition test of IO pins, but you could also test a variable, and you can take this block out and turn that into a function. So you just grab a function block, you wrap it around what you had. This one was called backwards.
So Linda, is your question, can you pass values to those functions?
Yes.
Okay.
Thank you.
I don't think that we can. What we do with Blockly is declare all global variables. And
Sure.
so yes, normally in say C language and most other text-based languages, you have the ability to say, okay, I wrote a function, and in order to call that function, I have to pass it this list of values.
Right, like parameters.
Yes, exactly. So your function has parameters. In fact, Ken, if you could hit the code button for a second.
Oh yeah, we need to demonstrate this briefly, don't we?
So down on line 34, between those empty parentheses is where normally you would put the parameter list. In Blockly, we don't do that because it basically opens up a room full of mirrors to student programmers. So that's a thing you graduate to in C. Now, if you want to make something happen the way you're describing, generally what we do is we put we declare some variables, and you can set them before going to the function. And since they're global, you set them in your main function, and then when you do the function call, those variables have been set to certain values already.
Okay, cool.
Other questions? Oh, how do you, okay, so let's do the C example right now. It's being asked in the chat. Okay, so how do we take this code, put it in C? If you want to do that, it's quite simple. You can just go over to this hamburger menu and then say download simple IDE files. All right, I'll do that right now. It's asking me where I want to put them. I'll drop them on the desktop. I'm just going to call it sample program. Save it. And then I'm going to go back to my desktop and extract it. And then you will go into Simple IDE, and I already have installed and I have the files associated. So I'll skip the whole installation, but you can go get Simple IDE from our website, install it, and then associate files. And then when you click on the side file, SIDE, here's your C code.
And it's ready to work with and start modifying. One quick all points bulletin I'd like to make is that Ken unzipped the zip file that he downloaded, and then he browsed into the folder that was created after he unzipped it. One of the most common mistakes I see people making with shared code is they are able to browse directly into the zip file. And then when they try to open a program into, say, Simple IDE, the Arduino IDE, pretty much any code development environment, if it's still in the zip file, you run into a problem somewhere or another. And so, so the best thing to do is to unzip the file and then open the folder it created.
Next question. What is the process to modify and send to the robot after alterations? So you make a change to your code and then download. I believe that's the question. And save in between too. So just click on the third button, provided you are connected. So process, I think, maybe asking about with the whole power supply, the robot rolling away, etc. Okay, here's the way I do it. I like to keep the robot switch in position 1, which powers everything but the motors. And then I can download to the robot using the third button. It's saved to EEPROM, or load and run. We talked about the second button last time, but I'll encourage you just use the third one. And the program downloads, but the motors cannot be powered because the switch is in position 1. So I like to come to the robot, undo the cable, and then put the switch in position 2. And this program, if you had a program that already had some drive routines, they would have already run without signals to the motors or without power to the motors. So you can reset it by pressing the blue reset button, or taking the power switch to position 0, then back to 2. You can also put a pause in the front of your program for 2 or 3 seconds so that you have time to unplug the cable. The videos will be available indefinitely. They're already on our YouTube channel. I found, since I watched them yesterday, they're a little bit boring from a user, a non-participant perspective, and everybody hates hearing themselves on video. I'll never watch one again. Andy sounds great, on the other hand, so does Stephanie, but they're on Parallax YouTube channel, which is right here. Take you over there really fast.
Meanwhile, I've been spamming Ken trying to get him to remove my workshop from Monday because I can't stand the way I sound either.
Oh. So the Parallax ones are, Parallax Inc. is our name on YouTube, and there's a playlist that has all of these videos in it called Distance Learning. And answer that question. Yeah, we'll leave them up for a while. Sometimes we do webinars, by the way, and we have whole students, entire classrooms participate in them. That's fun. They're welcome to do that. Other questions? And then we'll head towards, we'll close this out. I'm going to email you the homework assignment since a few had to leave already. Yeah, that's right. I was eating lunch in the last video. How awful can it get?
Hey, Ken, did we address some people who were needing help, who had problems with their servos?
I don't think so. We can take those up now, and I'll email the homework to everybody.
Okay.
It's going to be another circuit build.
Also, about troubleshooting your servos, if we don't get to where we need to be right now, we can also have one of us follow up with you. I know I'll be available after about 2:30, 3 p.m. Pacific time, and I could do either a phone call or a Google Hangout to do some troubleshooting.
I've found that most of these teachers end up emailing us, and we can re-engage. They have my email. Just launch off a message and we can sync up. But for anyone who has trouble that we've not addressed yet, we have 15 minutes. We can do that now.
I think Deborah needed some assistance, unless you got that squared away.
I've been working with Deborah and Andy, or I will be meeting with her sometime later today.
Perfect. I want to make sure that that wasn't overlooked. Anybody else stuck?
Yeah, actually, I kind of got stuck at test the whisker switches.
Okay. Can you show us where?
Oh, I got stuck in test the switches. So mines are at 1, 1 on my terminal, but then when I press one or the other, they both go to 0. Only one should go to 0, correct?
Correct. So 2 resistor leads may be touching each other. Also try physically holding back the whisker you don't want to touch. The other thing might be that your code might be displaying both WL variables, for example, as opposed to displaying WL and WR. So, so the thing to do would be to check your code against the example code and make sure that all the WLs and WRs are where they need to be. And then the second thing would be to make sure that both whiskers are not touching when you're only wanting to by both. The whiskers can touch each other, but we want to make sure only one whisker touches the post that's sticking out of the breadboard. Okay.
Marco, look at the screen here, and you'll see I have WL, WR. There's a good chance when you copy and pasted these that you did not change the second variable. So make sure in your code that one variable is WL and the other one is WR.
Also, right up above it, where it's WL equals check pin 7 and WR equals check pin 8.
We can share your screen if you want. If I stop share, let me see if I can pass over to him.
Or Marco, there's a share screen button at the bottom of your console when you wiggle your mouse over it.
I actually have it on a separate computer.
Oh, okay. Then the screen share is like you were doing to hold it up to us.
Yeah, get a little closer. Andy, press your face right into that monitor.
Yeah, yeah, you'll see my nose kind of go.
I'm trying. Marco, you could also just save that code off and send it off to one of us right now if you want. Hit save.
Okay.
And I can bring it up. Then email it to me.
Can you put the robot up close to the circuit up close to the? See if we can see anything. You can go closer. Oh, that looks good.
I spotted it for you.
Yeah, thank you.
Okay, hold that still.
Okay, so I see one issue, which is that your P14, it's an unrelated issue, but those P14 and 15 resistors
good catch.
Should come out. You can go ahead and pull out those P14 and P15 resistors.
We know how you wound up with those. We have an old set of tutorials that used external encoders and they required those. And so in your navigation tutorials, you came across that. That's a trap.
Okay.
Show us that again.
Yeah, let's come back.
Yeah.
I just took it off.
Oh, no, no, that's good. And
good.
So, so are those
10Ks.
yellow violet, those 10Ks, the vertical resistors, the ones that are connected to 5 volts, they look like yellow violet, they don't look like brown, black, orange. Can you double check those to see if there should be red, red, brown going to the pins, but then brown, black, orange going to either 3 or 5V, I forget which.
So the vertical ones are red, red, purple, orange. I'm sorry, red, red, purple, gold. So those are the wrong
red,
ones
red,
then.
Purple.
Check this out, Marco. I just brought up a picture that'll help you. Let me share it too. Are you looking at a picture of my circuit?
Yes.
Okay. And let me zoom in on a tad for you.
So yeah, they look the same. Yeah, they look the same. These are kind of the opposite.
Are your I/O pins correct? Starting on the left side, which I/O pins do you have the resistors plugged into? Are they 7 and 8?
Yes.
And then those are red, red, brown. And when they go over to the breadboard,
they are touching each other a little. Like
Are they also in the same row as, are they connected in the same row as the 3-pin headers on the right side?
Yeah.
Because I'm like, in my example here, I have a part in every single hole on the breadboard on the right side.
Not doing anything. Okay, that fixed it.
What was it?
Make sure. Right.
Can now okay?
Yeah, it's okay. I guess I was just looking at an older. Yeah, I'm not sure. I guess just taking out those 2 extra resistors helped.
Well,
Cool.
I don't think that actually changed the way the whisker circuit worked. That was more to make sure your motors are working okay.
But I also made sure the resistors weren't touching each other anymore.
Yep, that's the most likely culprit right there, is that 2 resistor leads were touching each other. Or
Okay.
yep, that's probably it.
All right. So yeah, those are the changes. Took those 2 other resistors and then made sure that these 4 resistors are now have more space between each other. Okay.
Also, looking at Ken's diagram, do you see where Ken's mouse is right now? See how that resistor is kind of getting really close to the whisker? So that's another gotcha, is like if you're pushing on the whisker and it touches the resistor lead, that would be another way to get a phantom, positive reading. Or actually,
Okay.
I think that would force it to be a did not detect reading.
Well,
Okay.
yeah, you don't
Not
get a
even sure.
3-dimensional view
The
here.
picture
Maybe.
you just had up is different than what's in the tutorial.
Okay.
Because the tutorial has us going in on the 3.3 volt on the left-hand side.
Gotcha.
So, and yours is going into the right-hand side. I don't know if that really makes a difference or not.
Well, really, you should be in 3.3 volts so you don't damage the I/O pins. But
Fortunately, the 10K resistors are large
thank
enough
you.
that the I/O pins are still protected. It's okay in this case, but there are other.
Okay, so time has come. Unfortunately, everyone have a good time who's left over here.
Yeah. Thank you very much.
All right, your next series of Bob Ross paintings tomorrow, and I'll send you some homework. Thank you. I hope we're learning a lot. I feel like you are, and having a good time.
I think you're probably better than Bob Ross, because I don't think he'd do this anymore.
He'd have to send you paints and easels and stuff.
From heaven, right?
Yeah, exactly.
Well, and then the other thing is, when I watch Bob Ross, when I watch Bob Ross, I'll try to do that painting, and it still looks kind of like something you put on the refrigerator from your 5-year-old. Whereas
my trees
got a
are
robot
not happy.
going.
My trees are not happy.